The relational model is very simple. The primary key of the one int becomes a foreign key in the many int. Nation, nation code, nation name, exchange rate, stock, stock code, stock name, stock price, stock quantity, stock dividend, stock P. Create table nation, net code SAR3, net name Varsar 20, X rate decimal 9/5, primary key net code double bracket. Create table stock, stock chart, stock farm, varchar, stock price decimal 6/20, stack tree decimal 5.8, stack deep decimal 5/2, scap tree decimal by 5, net code SAR3, primary key stock code, consultant FK stock nation, foreign key net code, references nation net code, NM relationship. NMM relationship is transformed into 1/m relationships. The mapping is them a twofold applications of the 1m rule. Book call no ISBN, book title, copy bokono, due date, borrower, borrowed. The book and browser tables must be created first because copy contains the foreign key constraints that refer to book and borrower. The column borrowed can be null because a book need not be borrowed if it's sitting on the shelf. There is no borrower. Created table book call no Varsar 12 ISBN book title primary key call no double bracket. Relational model would result in an additional column to contain a foreign key mother the personage of a person's mother. A recursive many to many M is to M relationship can describe a situation such as friendship. A person can have many friends and be a friend to many persons. As with MM relationships between a pair of integers, we convert this relationship to 1M relationships and create an associative entity. The resulting table friendship has a composite primary key based on the identifier of person, which in effect means the two components are based on the personage. To distinguish between them, these components are called personage 1 and personage 2. So you can think of friendship as a pair of personages. You will see the same pattern occurring with other recursive relationships. Notice both person identifiers are independent foreign keys because they are used to map to the two 1M relationships between person and friendships. Persons. Personate attribute 1, attribute 2. Friendship attribute 3, attribute 4. Create table person, personate, integer, attribute 1, attribute 2. Primary key, personate, creatable friendship, personate 1, integrator, personate 2, integrator, attribute 3, attribute 4. Primary key personal 1, personate 2, constraint, FK friendship personal 1, foreign key personate, reference personate, constraint, FK friendship person 2, foreign key personate, reference personate. A single entity can have multiple recursive relationship relationships such as enmity not enmity not enemyship, and siblinghood are recursive on person. The approach to recording these relationships is the same as that outlined previously. Two entities, no relationship. When there is no relationship between two entities, the client has decided there is no need to record a relationship between the two entities. When you when you uh, when you are reading the data model with the client, be sure that you check whether this assumption is correct both now and for the foreseeable future. When there is no relationships between two entities, map them each as you would a single entity with no relationships. A1 relationships, A11 relationships sometimes occurs in parallel 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 with a one relationship between two entities. It signifies some instance of an entity that have an additional role. For example, a department has many employees. The one relationship and at the department has one boss. The the data model fragment shown in the following figure represent the one relationship. Department debt table 2, department's boss, employee emped trip 1, emped trip 2. The guideline as explained in chapter 6 is to map the relationship to the relational model by placing the foreign key to minimize the number of instances when it will have a null value. In this case, we place the foreign key in department. A1M relationships. The 1M relationships is possibly this assist to understand and map the mapping to reference 1 basic structures. Reference 1 basic structures. Few things are harder to put up with than the annoyance of a good example. Mark Stein, Wood, Woodenhead, 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 Wilson, 1894. Every data model is composed of the same basic structure. This is a major advantage because you can focus on a small part of a full data model without being concerned about the rest of it. As a result, translation to the relational database is very easy because you systematically translate each basic structure. This section describes each of the basic structures and shows how they are mapped to a relational database. Because the mapping is shown as a diagram and SQL create statements, you will use this section frequently. One entity, no relationships. The unrelated entity was introduced in chapter 3. This is simply a flat file and the mapping is very simple. Although it is unlikely that you will have a data model with a single entity. The single entity is covered for completeness. Person, personate, attribute 1, attribute 2. A 1.1 recursive relationship. A recursive one-to-one relationship is used to describe situations like current marriage. In most countries, a person can legally have 0 or 1 countries and 1 current spouse. The relationship should be labeled, labeled, labeled to avoid misunderstandings. Mapping to the relational database requires that the identifier of one end of the relationships becomes a foreign key. It does not matter which one you select. Notice that when personate is used as a foreign key, it must be given a different column name, in this case partner, because two columns in the same table cannot have the same name. The foreign key constraint is not defined because this constraint cannot refer to the table being created. Spouse, person, personate, attribute 1, attribute 2. A recursive 1M relationship. A recursive one-to-many 1N relationship describes situation like fatherhood or motherhood. The following figure maps fatherhood. A father may have many biological children, but a child has only one biological father. The relationship is mapped like any other 1M relationship. The identifier of the one and become and foreign key. In the many int again we must rename the identifier when it becomes a foreign key in the same table. Also again, the foreign key constraint is not defined because it cannot refer the table being created. A recursive 1M relationships. It is possible to have more than 1M recursive relationship. For example, details of a mother-child relationship would be represented in the same manner and results in the data model having a second 1M recursive relationship. The mapping to the following information. SBUs are headquartered in one country, not necessarily the United States. Each SBU has sub, subsidiaries or foreign agents depending on local legal requirements is a number of countries. Each subsidiary or foreign agent operates in only one country but can operate in more than one market. GT uses the standard industrial code SIC to identify a market easy. Newspaper publishing, the SIC is a unique 4-digit code. Will foreign agents operate as separate legal entities? GT needs to know in what countries and market they operate. On the other hand, subscribers, subsidiaries are fully or partly owned by GT, and it is important for GT to know who are the other owners of any subsidiary and what percentage of the subsidiary they own. It is not unusual for a corporation to have shares in several of GT subsidiary companies and for several corporations to own a portion of a subsidiary. Multiple ownership can also occur at the SBU level. A real estate investment company owns many shopping malls. Each mall contains many shops. To encourage rental of its shops, the company gives a negotiated discount to retailers who have shops in more than one mall. Each shop generates an income stream that can vary from month to month because rental is based on a flat rental charge and negotiated percentage of sales revenue. Also, each shop has monthly expenses for scheduled and unscheduled maintenance. The company uses the data to compute its monthly net income per square meter for each shop and for ad hoc querying. Draw a date model for the following table taken from a magazine that evaluates consumer goods. The reports follow a standard fashion of listing a brand and model price overall score and then an evaluation of a series of attributes which can vary with the product. For example, the sample table evaluates stereo systems, a table for evaluating microwave ovens would have a similar layout, but different features would be reported. Easy cooking quality, brand and model, price overall score, sound quality, uh, tapping quality, FM thing, CD handling, each of use. Draw a data model for the following freight table taken from a mail order catalog. Merchandise subtotal, regular delivery, rush delivery 4 by 5 business days, express delivery 1 by 2 business days. References and additional readings. Carly's J. V. 199 by 1991. Logical data structures. Minneapolis, M.N. University of Minnesota. Hammer M. 1990. Ringineering. Work don't automate, obliterate. Harvard Business Review 68 4 is to 104 and 112. Exercise. Short answers. What is data modeling? What is useful technique for identifying entities in a written description of a data modeling problem? When do you label relationship? When is a data model well formed and when is it high-fidely? How do you handle expectation when data modeling? Describe the different types of entities. Why might a data model grow? Why might a data model contract? How do you indicate ordering of instance in a data model? What is the difference between a synonym and homonym? Data modeling. Create a data model from the following narratives, which are sometimes internationally incomplete. You will have to make some assumption, make certain you state this alongside your data model. Define the define the identifiers and attributes of each entity. The president of a book wholesaler has told you that she wants information about publishers, authors, and books. A university has many subject areas, e.g. MIS, Romance languages. Professors take in only one subject area, but the same subject area can have many professors. Professors can take many different countries in their subject area. An offering of a course, Easy Data Management 457, French 101, is taught by only one professor at a particular time. Kids and Vans Retail minivans for a number of manufacturers. Each manufacturer offers several models of its minivan EasyACLE GT. Each model comes with a standard set of equipment, e.g. the Acme AC comes with wheels, seats and an engine. Minivans can have a variety of additional equipment or accessories, radio, air conditioning, automatic transmission, airbag, etc. But not all accessories are available for all minivans, e.g. not all manufacturers offer a driver's side airbag. Some sets of accessories are sold as packages, e.g. the luxury package might include stereo, six speakers, cocktail bar, and twin overhead foxhotels. Steve operators Steve operates a cinema chain and has given you the following information. I have many cinemas. Each cinema can have multiple theaters. Movies are shown throughout the day starting at 11 a.m. and finishing at 1 a.m. Each movie is given a 2-hour time slot. We never show a movie in more than one theater at a time, but we do shift movies among theaters because seating capacity varies. I am interested in knowing how many people, classified by the adults and children, attended each showing of a movie. I vary ticket prices by the movie and time to slot. For instance, lazy, for instance, lazy get lost is 50 cents for everyone at 11 a.m. but is 75 cents at 1 all p.m. A university, a university, a university gymnastics team can have as many as 10 gymnasts. The team, the the team competes many times during the season. A meet can have one or more opponents and consists of four events: uh, vault, uneven bars, beam, and floor routine. A gymnast can participate in all or some of these events through. The team is limited to 5 participants in any event. The team limited to 5 participants in any event.